separation of a mixture. Separation of a mixture can be done by several different types of physical means. Sort of depends on the type of mixture that you have. One way to separate a mixture is by something called filtration. You've definitely separated a mixture by filtration at one time or another before. I kind of have some pictures up here of how we might do it in a lab setting. I separate a mixture by filtration every day when I brew coffee in a coffee maker. You have a piece of paper that does not allow the grounds to go through, but does allow the coffee that has been made from the water contacting those grounds. When you're a kid, you probably play with those sand toys where you have a little sifter, which allows you to separate out rocks and things like that from the smaller grains of sand. I really like this first picture on the left. You can kind of see, if you imagine a filter itself, whether it be a piece of filter paper or whatever, allowing a lot of these smaller particles through. It's called a filtrate, but blocking more of these larger purple particles and preventing them from going through. This is very often done in chemistry labs using a piece of filter paper and a funnel. It can kind of be a slow process. We don't really do it a whole lot in Regents chemistry. So filtration is a type of physical separation. Filtrate moves through the filter. Solid particles stay on the filter. And this is useful for separating heterogeneous mixtures based on particle size. The limitation to filtration is if you have particles that are all similar in size to one another, you're not going to be able to filter them. In a homogeneous mixture, that's actually why they cannot be filtered, because your particles are all very similar in size. So this is useful for heterogeneous mixtures with varying particle sizes. Evaporation. We'll actually do this in lab this year. This is also something that you observe when the salt kind of creeps up the back of your jeans in the wintertime. If you've been making some salt potatoes at home, you have that crusty white salt residue that gets left around. It's because the water's been evaporated away and the salt has been left behind. So evaporation is a physical separation also, as are all of these. You evaporate your liquid solvent away and leave behind a solid solute. So we will definitely see this in lab this year as we make some solutions which are homogeneous, which we need to be able to separate. So this is useful here because water tends to have a lower boiling point than a lot of the things that we dissolve in it. So we can evaporate away the water and leave behind the solid salt that was dissolved. This is nice because water and salt have very similar particle sizes, so this is not dependent on particle size. Distillation is actually an offshoot of this. When you distill something, you're essentially separating based on boiling point. There's a lab distillation apparatus shown here, pretty complicated looking. That's actually how you can distill water. We used to actually distill that for lab use in this room. We distill crude oil. They actually heat the crude oil in this large furnace. They pump the vapors into a really tall tower, and it's a lot cooler up here toward the top of the tower. So the different components of oil that we use for different things like natural gas and gasoline for our cars, things like that, get separated based on their boiling points. So this is separation of a component of mixtures based on different boiling points of those components. This can actually be used to separate various types of mixtures, as long as you have that separation, those different boiling points. Distillation of water, we'll use distilled water in lab a lot this year, is very common, as well as the distillation of crude oil, which is an important part of crude oil processing. And finally, chromatography. This is actually an absolutely huge category of separation. You might have done chromatography of ink before. You can kind of do like a little crime scene investigation activity. Chromatography will separate a mixture based on the different components of the mixture, either by their size, how well they dissolve in water, the shapes of the molecules. You can actually do a lot of different stuff with this. We're going to do a chromatography with food coloring later this year, so you can kind of see a little bit more what that's about. So this physical separation it might function on size or solubility depending on the type of chromatography. In living environment, you might have talked about gel electrophoresis. It has to actually do with electric charges in molecules. And this is able to separate homogeneous mixtures. Can actually separate heterogeneous mixtures as well, but it is able to separate even fairly similar particle sizes, which is nice.